So in a past unit, we talked about precipitation reactions, which are also called double replacement reactions or ionic reactions. And over here, we have two reactants, and this AQ means that they are dissolved in water. So we start with a solution, and then when they mix, we have a solid precipitate fall out, and then our other product is AQ. So that is still in solution. So we are going to talk about solution reactions and how we can quantitatively analyze them. But first, let's remind ourselves what these precipitation reactions look like and what these solutions look like. So my first one is going to be potassium iodide with lead nitrate, and my precipitate is going to be a yellow precipitate, lead iodide, and we're going to see this in slow motion. So that's the one drop, and I thought the slow-mo was really cool. And there's that one drop again, and instantly we form that solid yellow precipitate that falls out of solution. We're going to talk about potassium chromate and silver nitrate. Potassium chromate's yellow, silver nitrate's clear, and we're going to mix that. So we have a yellow potassium chromate solution and a clear silver nitrate, and we'll put these two together.
Yellow potassium chromate to colorless silver nitrate produces a red-orange precipitate.
So there we had a different color precipitate. So all these reactions are being run in solution. So here are your notes, and we're going to start working on solution chemistry. This is our next unit, and we need to start with our vocabulary. So we usually have something being dissolved in something, and we call our solvent, which is the substance doing the dissolving. Water is a universal solvent. It dissolves most things. Here I have the solid being dissolved in water, and that is sodium chloride, okay? So that's called our solute, and the solute is the substance being dissolved. So here's one vocabulary, solvent, and then when it's dissolved, what we have is we have sodium chloride aqueous, okay? And that is our solution. And solutions are homogeneous mixtures of solvent and solute. And remember, I talked about if it's a liquid or a gas, you know it's homogeneous if you can see through it. So some of our solutions are gas, gas, liquid gas, solid gas, when that dissolves in there, and you can see through it. There is one type of solution. It's a metal alloy, and that's a solid and a solid. Of course, you can't see solids, but it does look like one thing. So stainless steel looks like all one thing, and that's why a solid is still called a homogeneous mixture, but you can't see through that.